So what we're going to do is we're going to look at showing similarity between triangles on the coordinate plane. Now, in order to be able to do that, I think we need to review what similarity means. And I'm not 100% sure that we even went over this concept of similarity. We are going to see it in another unit, but let's go ahead and cover it right now. This symbol means similar, if you didn't remember that. So if we have two triangles, triangle ABC and triangle DEF, if they are similar, so if triangle ABC is similar to triangle DEF, then this will be true. If we were to divide the short side of triangle ABC by the short side of triangle DEF, and then divide the middle side of ABC by the middle side of DEF, and then divide the long side of ABC by the long side of DEF, we would come up with the same number. So this fraction would be equal to this fraction, and that would be equal to this fraction. Okay, it's called. It means that the sides are proportional to each other by a common factor or a common proportion. Okay, so let's do an example. Let's say that we have triangle ABC and we have triangle DEF. Let's say that segment AB is 9. So one side of triangle ABC is 9, another side of triangle ABC is 12, and another side of triangle ABC is 15. So this is the short side, 9, this is the middle side, 12, and this is the long side, 15. And then we have triangle DEF. The short side is 21, the middle side is 28, and the long side is 35. So this says, are triangle ABC and triangle DEF, are they similar? Well, there's an easy way to do this if we know the lengths of all the sides. All we have to do is divide the short side of ABC, or of ABC, by the short side of DEF, which is going to be 9 divided by 21. So we'll do 9 over 21, and that is... we can reduce this. 9 can be divided by 3, so that's 3, and 21 can be divided by 3, that's 7. Now we can do the middle side of ABC, 12, divided by the middle side of DEF. So that's 12 divided by 28. 12 can be divided by 4, and 28 can also be divided by 4. 12 divided by 4 is 3. 28 divided by 4 is 7. So look, we got the same fraction, 3/7. So the ratio or the proportion of small side to small side is 3:7, and the proportion of middle side to middle side is also 3/7. Now let's see if we get the same thing for long side to long side. So ABC, the long side is 15, DEF, the long side is 35, and 15 can be divided by 5, and 35 can also be divided by 5. So 15 divided by 5 is 3, and 35 divided by 5 is 7. And so look, 3/7, we got it. So all three of them, we come up with 3/7. So it's true that the short side fraction is equal to the middle side fraction, and it's equal to the long side fraction. And therefore, that means that triangle ABC is indeed similar to triangle DEF. Okay? But we know that they're not congruent. Why? Well, none of the sides are equal. You know, the short side on one is 9, the short side on the other is 21. So that's not congruent. Therefore, these two triangles, they're not congruent, but they are similar. Okay? And so what I'm going to do now is I'm going to show you how we can show whether two triangles on the coordinate plane are similar by using this same circumstance where we take the short sides of two triangles and divide them, take the middle sides of two triangles and divide them, and take the long sides of two triangles and then divide them. Okay, so suppose that you're given the coordinates of the vertices of two triangles on the coordinate plane. So you're basically given 6 points. 3 of those points, so 3 of those points belong to one triangle, and 3 of those points belong to another triangle. And so you want to determine if the two triangles are similar. Okay, so here's the procedure. The first thing you're going to do is you're going to use the distance formula to calculate the shortest, middle, and longest sides of the two triangles. Now let's briefly review the distance formula. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, the next thing you're going to do is you're going to make three fractions. The first one is going to be the longest side of the larger triangle divided by the longest side of the smaller triangle. The second fraction is going to be the middle side of the larger triangle divided by the middle side of the smaller triangle. And of course, the third fraction is going to be the smallest side of the larger triangle divided by the smallest side of the smaller triangle. Now, it is very likely that all of these numbers that you have in these fractions are either radicals or they are decimals. Okay, now if you're doing decimals, make sure you're going out several decimal places, maybe 6 or 7 decimal places. Okay, but if they're radicals, that's okay. But what we're going to do is it's going to be hard to tell whether this fraction with radicals is going to be comparable to this fraction or this fraction. So what we're going to do is we're going to turn each of these fractions into a decimal. So then what you're going to do is you're going to plug each one of these three fractions into a calculator to convert each fraction into a decimal. If all three decimal values are equal, then the two triangles are similar. All right, so I think now we should do an example. All right, so here's our example. Triangle ABC has vertices at A is at 3, 1, B is at 7, -9, and point C is at 13, -7. Triangle DEF has vertices, point D is at 1, 8, E is at -4, 10, and F is at -3, 13. And we want to know, is triangle ABC similar to triangle DEF? Okay. So here's what we need. We need the sides of the lengths of the sides of the triangle. So we have a side of the triangle that goes from A to B. So we're going to call that segment AB. And the measure of segment AB, we'll get to that in a minute. We have B to C, so we'll have the measure from B to C. That'll be one side of the triangle. And then one side of the triangle is going to go from A to C. So we need the measure from A to C. All right. Then we're going to need the measure in the other triangle from D to E. So we need the measure of side DE. We're going to need the measure of side DF. Measure of DF. And then we're going to need the measure from E to F. All right, so we need the measure from E to F. All right, so we have D to E, E to F, and D to F. Okay, so we got to do the distance formula 3 times. Now, I want to remind you about, I think I showed you at some point, sort of a shortcut way of using the distance formula. So we can say that the distance is equal to the square root of, and then what we can do is this. So if we want to do AB, A to B, basically we just say, well, how far is it from 3 to 7? Well, that's 7 minus 3. 7 minus 3 is 4. So this is going to be 4 squared plus. Then how far is it from 1 to negative 9, or from negative 9 to 1? Now you may know that on the coordinate plane, or you can just do 1 minus negative 9. Well, 1 minus negative 9 is the same thing as 1 plus 9, which is 10. So 10 squared. So the x distance is 4 and the y distance is 10. Okay? So our distance, the measure of AB, is going to be equal to the square root of 4 squared, which is 16, plus 10 squared, which is 100. So it's the square root of 16 plus 100, which is the square root of 116. So the measure of side AB is the square root of 116. I'm going to leave it in square root form. I'm not going to convert it into decimal form because I'm going to do the decimal form when I do the fractions. Okay. All right, let's go to BC. BC is going from 7, 9 to 13, negative 7. 7, negative 9 to 13, negative 7. Well, how far is it from 7 to 13? Well, we can just do 13 minus 7. That's 6. So we're going to do 6 squared plus. Then how far is it from negative 9 to negative 7? So here's another way to do it. We could draw a number line, and here's 0 on the number line, and here's negative 1, and here's negative 2, and here's negative 3, and here's negative 4, and here's negative 5, and then negative 6, and then negative 7, and then negative 8, and then negative 9. Well, how far is it from negative 9 to negative 7? Well, it's only 2 units away. 1, 2. And therefore, negative 9 minus negative 7, it's actually negative 2, but we're squaring it. So that's the same thing as 2 squared. Okay? So this is going to be the square root of 36 squared, 6 squared is 36, plus 2 squared is 4. So put a 4 here. So it's the square root of 36 plus 4, which is the square root of 40. And so that is the measure of BC. It's the square root of 40. Now let's do AC. AC is going from 3, 1 to 13, 7. So how far is it from 3 to 13? Well, 13 minus 3 is 10. So the distance is going to be the square root of 10 squared plus. How far is it from 1 to negative 7? Well, we could do 1 minus negative 7 to find that. Well, 1 minus negative means plus, so 1 plus 7 is 8. So that's going to be 8 squared. So this is the square root of 10 squared is 100 plus 8 squared is 64. And so that's the square root of 164. And so that is the length of side AC. It's the square root of 164. So we can see that AC, the square root of 164, that's the larger side. Square root of 40, BC, that's the shorter side. And then the square root of 116 is in between the square root of 40 and the square root of 164. So that's our middle side. Okay. Now let's do the same thing for these 3 sides on DEF. Okay, so let's do the measure of DE going from D to E. How far is it from 1 to negative 4? Well, we can do 1 minus negative 4. That's how we find the distance between 2 numbers, is we do one number minus the other, and we do the absolute value. We make it a positive number. Okay, so negative 1 minus negative 4, 1 minus negative 4 is the same thing as plus 4. That's 5. So the distance is going to be the square root of 5 squared plus. Then how far is it from 8 to 10? Well, 10 minus 8 is 2. So that's 2 squared. So 5 squared is 25 plus 2 squared is 4. So 25 plus 4 is 29. So that's the square root of 29. So DE is the square root of 29. Now let's do from D to F. So 1, 8 up to negative 3, 13. Well, how far is it from 1 to negative 3? Those are the x values. Well, if we did negative 3 minus 1, that's negative 4, but then we make it positive. So we have the square root of 4 squared plus. How far is it from 8 to 13? Well, 13 minus 8 is 5, so that's 5 squared. So that's the square root of 4 squared here. That's 16 plus 5 squared is 25. 16 plus 25, that's 41, so we have the square root of 41. Now, that square root of 41 is larger than the square root of 29, so DF is a longer side than DE. Okay. Now let's do from E to F. We're going from -4 up to -3. Well, that's only one apart. -4 is right next to -3. They're 1 unit apart. So that's going to be 1 squared plus. How far is it from 10 to 13? Well, those are 3 apart. 13 minus 10 is 3. So that's 3 squared. So that's the square root. 1 squared is 1 plus 3 squared is 9. And so the square root of 1 plus 9 is the square root of 10. That looks like the shortest side here. So the shortest side of this triangle is EF with the square root of 10. The middle side is DE with the square root of 29. And the longest side is DF with the square root of 41. Okay? All right, now we're going to look back at our procedure to see what we should do next. All right, so we used the distance formula to calculate the shortest, middle, and longest sides for both of the triangles. Okay, now we're going to make 3 fractions. We're going to do the longest from the larger triangle. It looked like ABC was the larger triangle. So we'll put the longest side of ABC in the numerator and then the longest side of DEF in the denominator. Then another fraction will be the middle of ABC divided by the middle of DEF. Then the smallest side of ABC divided by the smallest side of DEF. And then after we make those fractions, we're supposed to plug each fraction into a calculator and convert each one into a decimal. And then we're supposed to see if all 3 of those decimal values are equal. If they are equal, then the 2 triangles are similar. If they're not equal, then they're not similar. Okay, so larger over larger. So here's larger, square root of 164. Square root of 164 divided by the larger down here is the square root of 41. Square root of 41. We're going to put that in a calculator in a minute. Now we'll do the middle, square root of 116. Square root of 116. Divided by the square root of, middle down here is 29. 29. And then the smaller one is going to be the square root of 40. Square root of 40 divided by the square root of 10. Okay. All right. So I'm going to switch over to the NumWorks calculator. All right, here we are at the NumWorks calculator. I'm going to go to full screen here. And I'm going to use the calculation. So I'm going to hit OK. And now it looks like I need the square root of 164 over the square root of 41. All right, so I'm going to do the square root of 164 divided by the square root of 41. And let's see what we get. 2. We get 2. Okay, well, that's easy. All right, so this is equal to 2. Now let's do the square root of 116 over the square root of 29. So we'll do the square root of 116 divided by the square root of, what did it say, 29? Let me check. Yep, 29. We'll hit execute. Oh, yep, we got a 2 again. Same value. Put 2 here. Now we'll do the square root of 40 over the square root of 10. So we'll do the square root of 40 divided by the square root of 10. And sure enough, we get 2. And since all 3 fractions are the same value, 2 equals 2 equals 2, we can say that triangle ABC is similar to triangle DEF.